Hi everyone, welcome back to my YouTube channel. Today I'm going through the notes of chapter 2, which is data models and query language. The focus of this chapter was why data model matters and why query language matters. Now, what is data model? Data model is basically when we have given a data, we need to think about how we are going to structure it. Now, why it matters? It matters because if we are gonna pick a wrong data model, it is gonna cost us the performance. It is gonna slow down our engineers. It is gonna slow down the queries. As I told you, performance. It would be hard for us to scale also our application. So that's why it's very important. Now, what was my takeaway from this whole chapter? That there is no one size fits all. What it means is that no one can say, oh, this particular data model is the best. The reason is if it doesn't know the context, that what was the use case, what kind of application that person was creating, how the data was getting used within the application, and how it is getting used outside. It is very hard, it is impossible to say confidently that this is the best data model. So there is no size fits all. Every engineer has to do their own exercise. They need to understand that when the data is given to them, they need to do a whiteboarding exercise where they need to understand the data and their application, that how that data is going to use in application, how it is going to use internally between the components of your application, what kind of access patterns are there. So from this book, this is the quote, I actually loved it: your data model should be driven by your application's access pattern. So please remember this. So in short, data model should be how it should look structured and how it retrieve is matter, because it is going to help you with your architectural decision. Uh, so why it matters, this is we will learn now. Now, why it matters? Because if you are gonna pick the right model, it will help you to easy to query. So as I mentioned about access patterns, uh, it is very important that how once the data is structured and stored, how you can get you can query it and get the necessary information and faster. That is also important. How quickly it will evolve. So whenever new data is coming, new schema changes are coming, how quickly we can change it, it matters. And if the load on your application is there, how it is going to perform in it under the load. So every data model which I'm going to discuss, and basically in this chapter discuss, has pros and cons. So that's why there is no one size fits all. What you need to understand is you need to again look at your use case and then decide which kind of data model you require. Okay, so the first one is relational, which is basically tables and row. You have the example of MySQL. The data in relational is getting organized in table and row, and we use SQL as a query language to retrieve the data from it. Now in this book, there is an example given of Bill Gates resume. So imagine you have a Bill Gates resume and you want to store it. Now by using relational, what I will do is I will create different tables. So I will create a table of user where I will put Bill Gates with key, the ID, email, phone number. Then another table for education, another table for experience, and so on. And then I will relate them. So whenever a query is coming, I have to write the queries to get the specific information from all these tables. So this is how I'm gonna organize, or this is how I'm gonna use the model relational to store Bill Gates resume. Now, what are the pros of this? What is the benefit? The benefit is the relation database is the most oldest one, and it's still going on. So that's the, I would say, community is strong. It's still standing tall, so it's pretty trustworthy. Joins are easy and powerful. So now I have created multiple tables. So whenever I need to query something out of it, I can just write the joins and get the required information from multiple tables. As well as in SQL, writing the queries are pretty straightforward, so easy peasy to write. And data is normalized because I have now distributed that Bill Gates resume in different tables, so it is normalized. But it doesn't mean it is the best one. If I have to change the schema, if I have to change anything, if a change came in the resume template, I have to go through a pain to change everything. Joins are easy, but if I'm gonna do any complex join, it will be expensive. So you need to think about the trade-offs. With every architect decision, there are trade-offs, so please think about it. Now, second is document, which we famously also say no relational. Basically, in this, documents and collections are there. Example is MongoDB. Data gets saved in pages or collection. There is a JSON like structure in which we save it. Now, if I will take the same example of Bill Gates, instead of putting it into the table, I will create a JSON structure and put everything. So one document of Bill Gates and everything will go there. So one resume, whole JSON structure. Now, what is the pros? Schema is flexible. I can change it on very easily, very easy to scale. I can keep adding faster reads because there are no tables, no relationship I'm building. It's just a JSON, so no joins are there, no complexity. Amazing for nested data, definitely. So now, because what I have done is created a nested JSON doc of the resume. So creating the nesting in JSON, I think everyone knows it's easier. Now, it doesn't mean it's the best. Again, there are cons. Harder to update consistently. So if you have to keep updating it, it is gonna be a pain because the query language is different here. So you need to write extra code. Duplication is easier here, definitely. In relational one, this is what you are getting. There is an asset property, there is a consistency. In upcoming chapters summary, I'm gonna explain those also, which is missing from our document one. So duplication is easier here. Now in data, duplication is not a good trait to have. I hope you know why. So think about it. There should not be duplicate data. So this could be a con here. Then the third one is graph, nodes and edges. Example is Neo4j. Here, where the relationship are complex, then graph models come in picture. Any application which is relationship heavy, like social media apps, recommendation app, there you are gonna use. Now, one of the use cases is when we see on Instagram or Facebook that our friend of friend like a post, a friend of friend like a photo. That is basically our connection. What Facebook is doing is it is leveraging our connection to show that what our friends or friend are doing. So this is where it shines the most. So use it where you need to target the connections. So very straightforward use case of graph model. Wherever you need to target the connections, you are gonna use the graph one. Basically relationship, connections, recommendation systems, apps work on this. Okay, we already discussed the query language like SQL, NoSQL and GraphQL, so I will leave it here. But one of the question was, can we merge it all these three data models in one same application? Yes, we can do it. So if we will take the example of e-commerce application, for the users we are onboarding, we can actually create a table for them to have their record, their orders, their products, and all the user details can go as a document. And when I want to implement the recommendations on my e-commerce application, I will use the graph model. So yes, we can merge all this. So this is about the chapter 2, where the focus was why data model matters, why query language matters, different kind of data models, different kind of query languages. So this was about this chapter, and I will see you in the next video where we are gonna talk about the storage and retrieval in our application. So thank you for watching. See you. Bye.